There's a photograph taken by the Curiosity rover in 2012 that most people have never seen, not because it's classified or hidden, but because it isn't dramatic. It's just a hillside. Rocks, dust, a sky the color of a faded bruise. Nothing moves, nothing ever will. And when you look at it long enough, something shifts inside you, because what you're actually looking at isn't a landscape. It's a question. A question humanity has been quietly building toward for the better part of a century, and that we are now, finally, close enough to answer in the most literal way imaginable. Can we live there? Not visit, not plant a flag and come home to ticker tape parades, but actually live there, build something that lasts, raise children, bury the dead, forget, eventually, what Earth smelled like. Most of the debate around Mars colonization circles around rockets and radiation shields and water extraction technology, and those things matter enormously. But they might not be the hardest part. They might not even be close to the hardest part. This is a story about what happens after we land. There's something almost inevitable about the way humans talk about Mars. Not inevitable in the way that physics is inevitable, but in the way that certain ideas feel so old and so deeply embedded in our imagination that they start to seem like destiny rather than choice. We have been watching Mars for a very long time. Ancient astronomers tracked its wandering path across the sky with careful attention, noting that unlike the fixed stars, this reddish point of light moved, paused, reversed, moved again. It was strange. It stood out. Civilizations across the world assigned it significance, usually something martial, something urgent. The Romans named it for their god of war. The Babylonians saw it as a wandering eye in the heavens. In cultures that had no contact with each other, Mars consistently attracted a kind of weighted attention that the other planets didn't quite earn. Which tells you something interesting, not about Mars, but about us. We were drawn to it before we had any reason to think it was anything more than a light in the sky. And then, as telescopes improved and we started to see it more clearly, the attraction intensified rather than dissipated, because what we saw was almost suspiciously familiar. A day on Mars lasts 24 hours and 37 minutes. That's close enough to Earth that you might not even notice the difference at first, at least not consciously. Mars has seasons, caused by the same axial tilt mechanism that governs our own. It has polar ice caps that grow and shrink with the Martian year. It has vast flat plains and ancient riverbeds and mountains that dwarf anything on Earth, including Olympus Mons, a shield volcano so large that its base would cover the state of Arizona, and its summit rises so high into the thin Martian atmosphere that you could stand at its peak and technically be in space. In the 19th century, when Italian astronomer Giovanni Schiaparelli announced that he had observed what appeared to be linear features on the Martian surface, the American astronomer Percival Lowell took that observation and ran with it. He built an observatory in Arizona specifically to study Mars. He spent years drawing maps of what he believed were canals, vast engineering projects, evidence of a dying civilization attempting to move water from the polar caps to the equatorial regions. Lowell was wrong, and we've known that for a long time now. But his wrongness is less interesting than the direction he was wrong in. he looked at Mars and saw people. He saw struggle and ingenuity, and a civilization fighting against the odds. He projected human drama onto an empty landscape, and millions of people read his books and believed him, or wanted to. We are a species that finds it extraordinarily difficult not to see ourselves wherever we look, and Mars, more than any other world in our solar system, looks back in a way that feels almost like recognition. By the mid-20th century, rocketry had transformed from theory into catastrophic reality, and the space race compressed decades of scientific ambition into a frantic political competition. The Soviet and American programs launched probes, orbiters, landers. Mariner 4 flew past Mars in 1965 and sent back 21 grainy photographs. They showed craters. They showed a world that looked more like the moon than the canal-crossed civilization Lowell had imagined. For a moment, the dream deflated. But deflated is not the same as extinguished. By the time Viking 1 landed in 1976 and sent back the first photographs from the surface, the conversation had shifted from whether Mars had life to whether Mars could ever support it, whether we could bring life there ourselves, whether the question of Mars and the question of human survival had always been, on some level, the same question. That link between Mars and survival is not just rhetorical. It has a practical logic that has only grown more compelling in recent decades. Earth is finite. That sounds obvious, but the implications are staggering once you really sit with them. Every species, every ecosystem, every civilization in the history of this planet has existed on a single world with a single set of resources and a single set of risks. We have never had redundancy. We have never had a backup. And the number of ways in which that single world can be compromised by asteroid impact, by pandemic, by volcanic winter, by the slow accumulation of our own industrial byproducts is not zero. It's not even particularly small. The philosopher Derek Parfit wrote about what he called the importance of the long run. He argued that because there could theoretically be an astronomically large number of future humans, the prevention of human extinction is among the most morally significant things we could possibly do. Even a small reduction in the probability of our extinction, he suggested, could be worth almost any cost in the present. You don't have to accept his entire framework to feel the weight of the underlying logic. The stakes of the single-planet scenario are genuinely, terrifyingly high, and so Mars begins to feel not just like an adventure, but like a kind of planetary life insurance policy, a hedge against the catastrophic. A way of answering the question that every parent instinctively understands. What happens to the children if something goes wrong? Elon Musk has spoken about this with an almost religious intensity. He wants a self-sustaining city of 1 million people on Mars within his lifetime. And while that timeline is almost certainly optimistic to the point of fantasy, the underlying motivation, the drive to make humanity multiplanetary before our luck on Earth runs out, has attracted genuine, serious scientific support. NASA has spent decades and billions of dollars developing Mars mission architecture. The European Space Agency has contributed. China has landed a rover. The conversation has moved, slowly and then quickly, from whether humanity will ever go to Mars to when and how and at what cost. Which brings us, finally, to the part of the story that most people overlook. Because the cost it turns out, is not just financial, it's not just technical, and it's not just dangerous in the ways that brochures about space exploration tend to describe. The radiation charts and the fuel equations and the long list of engineering problems that have to be solved before the first boot hits the red soil. The cost is something older and stranger than any of those things, and it starts, as most of humanity's deepest problems do, with the human mind itself. It would be dishonest to skip past the technical challenges entirely, partly because they're real and serious, and partly because understanding them is necessary context for the deeper problem that comes after. The journey itself is the first gauntlet, a one-way trip from Earth to Mars, depending on orbital positioning, takes between 6 and 9 months. The two planets are not always equally distant from each other, and the windows when travel is most efficient, when the relative positions of Earth and Mars allow for the most fuel-efficient trajectory, open only once every 26 months or so. This means that if something goes wrong on the Martian surface, help is not coming quickly. It is not coming at all for at least 2 years in most scenarios, probably longer. During those months in transit, astronauts will be confined to a spacecraft that, for any mission remotely within the realm of current engineering and economic possibility, will be small. They will be exposed to cosmic radiation in a way that Earth's magnetic field normally prevents. Estimates vary, but a round trip to Mars using conventional propulsion could expose a crew member to radiation doses that meaningfully increase their lifetime cancer risk, and that's before accounting for any solar particle events, sudden surges of charged particles from the sun that could irradiate an unshielded spacecraft in ways that existing shielding technology cannot fully mitigate. On the surface, the challenges multiply. Mars has an atmosphere, but it's not much of one. It's about 1% the density of Earth's atmosphere, composed primarily of carbon dioxide, with traces of nitrogen and argon. It provides almost no protection against ultraviolet radiation and virtually no insulating effect. Surface temperatures range from around 20 degrees Celsius at the equator on a warm afternoon to negative 125 degrees at the poles in winter. The wind, despite the thin atmosphere, can move fast enough to create dust storms that occasionally engulf the entire planet for weeks or months at a time, significantly reducing solar power generation. Water exists on Mars, mostly frozen in the polar caps and in subsurface ice deposits, but extracting it in sufficient quantities for a human settlement is a non-trivial engineering problem. Growing food requires solving the problem of Martian soil, which is both nutrient-poor and laced with perchlorates, toxic compounds that would need to be removed before the soil could support plant life, even in pressurized greenhouses. The construction of habitats strong enough to hold breathable air at Earth-equivalent pressure, in a thin atmosphere that exerts almost no external support, requires materials and construction techniques that have never been tested at scale. All of these problems are solvable. That's important to say clearly. They are solvable. Brilliant engineers and scientists are working on them, and they will continue to work on them, and over the next several decades, solutions will emerge. Some will be elegant. Some will be brutally pragmatic. Some will fail in ways nobody predicted, and those failures will be incorporated into the next design iteration, and that process will continue until the problems are solved well enough for humans to survive on Mars at least in small numbers, at least for defined mission durations. But here's the thing that doesn't get discussed enough. Surviving is not the same as thriving. A mission to Mars where a crew of 6 lives for 2 years in an underground habitat and then returns to Earth is a survival scenario. It's extraordinary in its own right. It's a technical achievement of the first order. But it's not colonization. It's not a civilization. It's a camping trip to the most hostile camping destination in the solar system. Colonization means permanence. It means growth. It means people choosing to live and die on Mars not because they've been selected by a space agency and trained for years and compensated with the entire weight of institutional support, but because Mars is home, because it's where they were born, or because they chose it freely, or because it's simply where their life is. And that is where the conversation has to shift, because the obstacles to making Mars genuinely habitable in that deeper sense, not just survivable, but livable, are not primarily technical. They are human. And human problems are, in many ways, far more difficult to engineer around than atmospheric pressure differentials. There's a moment in every long-duration space mission, documented in the psychological literature with quiet consistency, that mission planners refer to informally as the third quarter phenomenon. Roughly 3/4 of the way through a long mission, something happens to crew members. Their motivation dips. Interpersonal conflicts that had been manageable become irritating and then maddening. People start withdrawing into themselves. Errors increase. Communication with mission control becomes strained. It happens on submarines. It happens at Antarctic research stations. It happened on the Mir space station. It happens on the International Space Station. It has been studied and predicted and planned around, and it still happens with remarkable regularity because it isn't a failure of planning. It's an expression of something fundamental about how human minds relate to time and confinement and the slow erosion of novelty. Now imagine the third quarter phenomenon in a context where the mission doesn't end. That's the psychological reality that colonization actually implies. Not a 6-month journey with a return ticket waiting on the other end. Not a 2-year surface mission with an agreed-upon evacuation plan, but a life, an indefinite commitment to an environment that is hostile by default, where every single element of breathable air and drinkable water and edible food requires active maintenance and could, if systems fail in the wrong sequence, cease to exist within hours. The technical challenges of Mars colonization get the headlines because they're legible. You can draw a diagram of a problem with radiation shielding. You can publish a paper about perchlorate remediation. You can run a cost-benefit analysis on different propulsion systems. These things are concrete and bounded, and progress on them is measurable. But what does progress look like on the question of how a human being maintains psychological coherence over decades in an environment with a surface gravity only 38% of what their body evolved for, with an artificial sky above them instead of a real one, with a communication delay that makes real-time conversation with anyone they've ever loved effectively impossible? What does progress look like on the question of what it means to grieve on Mars for a parent who died on Earth, knowing that you can never visit the grave and that the only record of the funeral you'll ever have is a compressed video file that arrived 18 minutes after it was sent? These are not rhetorical questions. They are engineering problems for a different kind of engineer. And unlike the problem of propulsion or habitat construction, they do not have clear specifications, and they will not be solved cleanly before the first colonists arrive. Let's talk about what isolation actually does to people. Not the dramatic version, not the Hollywood version where someone goes quietly crazy and starts talking to volleyballs. The real version. The one that's documented in journals and in astronaut debriefs and in the private notes of Antarctic winter rovers who emerge from their stations after 9 months of darkness, changed in ways that are subtle and profound, and sometimes permanent. Human beings are, at their core, social animals. This is not a soft observation about our preferences. It is a hard biological fact about our architecture. Our nervous systems are calibrated at a level that predates conscious thought by hundreds of millions of years to read and respond to other human beings. The presence of other people, specifically people we trust, regulates our cortisol levels, our heart rate, our sleep patterns, our immune function. Touch, specifically human touch, releases oxytocin in ways that measurably affect our physiology. The sound of a familiar voice can shift our nervous system from a stress response into a rest and digest state within seconds. What happens when you take all of that away? The research on solitary confinement, on long-duration isolation studies, and on the experience of people who have spent extended time in genuinely remote environments is consistent and somewhat disturbing. After a few weeks, the psychophysiological effects of social deprivation begin to compound. Anxiety increases, rumination deepens. The ability to accurately interpret other people's emotions, always imperfect, degrades further. Small irritations become large ones. Large ones become consuming. The mind, deprived of adequate social input, begins generating its own, often in distorted and dysregulated forms. In the context of an Antarctic research station or a submarine, these effects are managed because everyone knows the duration. There is a date on the calendar, a flight home, a bar in the nearest city that represents the end of the ordeal and the return to ordinary life. The knowledge that the isolation is bounded is itself a form of psychological protection. It gives the suffering a shape, a trajectory, a meaning it would otherwise lack. On Mars, permanently and with no intention of returning, there is no date on the calendar. There is no flight home. The Earth is visible in the Martian sky as a small blue dot, recognizable to a careful observer, but not warm, not close, not reachable in any practical sense. The colonists who chose to stay, or who were born there, will have to construct a relationship with that fact over the course of their entire lives. And here's the thing that no psychological study can fully prepare you for. The relationship between voluntary choice and suffering is not as straightforward as it sounds. We assume that if someone chooses a difficult situation, they will cope with it better than if they were forced into it. And there's some truth to that, at least initially. But voluntary choices made in moments of high motivation and social support do not always sustain their psychological power over years and decades, particularly if the choice cannot be reversed. The first colonists will have chosen Mars. Their children will not have chosen Mars. Their children will simply have been born there, into an environment they never agreed to, facing constraints they did not select. The psychology of that, of being Martian-born in a civilization that has yet to develop a genuine Martian culture, is one of the least discussed and most consequential aspects of what colonization actually means. Children who grow up in physically restrictive, psychologically pressured, socially limited environments do not, as a rule, simply adapt and thrive. They develop, they cope. They build identities out of whatever materials are available. And sometimes those identities are resilient and creative and extraordinary. But sometimes they're shaped by resentment and claustrophobia and a longing for something they've never experienced but somehow know they're missing. This is before we've even touched on the biological dimension. Human bodies evolved on Earth. This seems obvious, but the implications run very deep. Every system in the human body, every organ, every tissue, every biochemical process was shaped by natural selection operating in Earth's gravity, under Earth's atmospheric composition, with Earth's specific cocktail of atmospheric pressure, light cycles, and electromagnetic environment. We are, at a cellular level, Earth creatures. On Mars, the surface gravity is 38% of Earth's. That sounds manageable. It probably is manageable for short periods. But over years and decades, the effects of living in reduced gravity on human physiology are not well understood, and what evidence we do have is concerning. Microgravity on the International Space Station, which is more extreme than Martian gravity, but provides the closest analog we currently have, causes bone density to decrease at rates of roughly 1 to 2% per month without aggressive exercise countermeasures. It causes muscle wasting. It causes fluid shifts in the body that affect vision, sometimes permanently, through a mechanism called spaceflight-associated neuroocular syndrome, which involves intracranial pressure changes that can alter the shape of the eye and compromise visual acuity. Martian gravity is not microgravity. It's somewhere in between, and we don't have good long-term data on what living in 1/3 gravity does to a human body over a decade, let alone a lifetime. We don't know if the cardiovascular system adapts in ways that are ultimately sustainable. We don't know if bone loss reaches an equilibrium or continues to progress. We definitely don't know what happens to children who grow up in 1/3 gravity, whether their musculoskeletal development is fundamentally altered in ways that would make it difficult or even dangerous for them to ever travel to Earth. And there's the staggering possibility, not yet proven but biologically plausible, that humans born on Mars might not be able to go to Earth. That they could be gravitationally stranded, their bodies adapted to a lighter world, unable to survive the crushing normality of the planet their species came from. This would not simply be a personal inconvenience. It would be the beginning of a speciation event, the first divergence of the human lineage since Homo sapiens spread across Africa. It would represent a biological rupture that is, depending on your perspective, either one of the most profound moments in our species' history or a quiet, irreversible tragedy. We should also talk about radiation, but not in the technical sense, in the human sense. Because there is something uniquely psychologically wearing about living in an environment where one of the primary threats to your health is invisible, constant, and incurable. You cannot feel radiation. You cannot hear it or smell it or respond to it the way you can respond to visible danger. It simply accumulates, It damages DNA with each passing day. The colonists will know, in the abstract, that their cells are sustaining damage that probabilistically increases their cancer risk. They will know that their habitat provides partial but not complete shielding. They will live with that knowledge, the way people who live near industrial pollutants or in high radon areas sometimes live with background anxiety, not overwhelming, not incapacitating, but present, a hum beneath every other thought. Over years, that hum has psychological effects, not just anxiety, but a kind of relationship with mortality that is different from the ordinary human relationship with death. Most of us, most of the time, live with death at a comfortable cognitive distance. We know it's coming. We don't usually know when. And that uncertainty, paradoxically, allows us to proceed with daily life as though death is something that happens to other people until suddenly it doesn't. Mars colonists, living with measurable daily radiation exposure and the knowledge that their planet's thin atmosphere provides almost no shielding from cosmic rays, will have a more present relationship with their own mortality than most humans in history have had. That might sound noble. It might even have certain philosophical advantages. But over years and generations, maintaining a healthy relationship with that knowledge, rather than a nihilistic or anxious one, requires cultural resources that don't yet exist. The first colonists will need to build not just habitats and power grids, but a relationship with death that sustains rather than corrodes human flourishing. They will need to invent, effectively from scratch, the existential frameworks that allow a community to keep going in the face of constant, low-grade risk. Now add to this the structural stresses of a colony that is, at least initially, entirely dependent on Earth for survival. The communication delay between Earth and Mars ranges from 3 to 22 minutes one way, depending on orbital positions. At maximum separation, a question and its answer take 44 minutes to complete. This makes genuine real-time conversation impossible. It makes teleconferencing impossible. It means that in the event of an emergency, by the time mission controllers on Earth have received a distress call and sent back instructions, the emergency has either resolved itself one way or another, or is in the process of resolving itself. The colonists will be making life or death decisions entirely on their own because they will have no other option. This requires a kind of psychological and practical autonomy that is easy to endorse in principle and very difficult to actually live. The Apollo astronauts on the lunar surface were 3 days from Earth and had mission controllers on the line in real time. Even that felt profoundly isolated. The colonists on Mars will be months from Earth and effectively unreachable in any crisis. Every decision, including medical decisions, engineering decisions, decisions about resource allocation and interpersonal conflict resolution, will be made by a small group of people who are simultaneously exhausted, stressed, physiologically compromised, and psychologically dependent on each other in ways that can easily tip from support into conflict. Small group dynamics in confined high-stress environments are not trivial problems. The history of exploration is littered with expeditions that failed not because of equipment failures or weather, but because the humans involved stopped being able to cooperate. Ernest Shackleton's leadership during the Endurance expedition has been celebrated for decades, specifically because it was so exceptional, so unusual in its effectiveness, that it became a model studied in business schools a century later. The fact that it's celebrated as a model suggests how rare it actually was. Most groups of people under extreme stress do not produce Shackletons. They produce friction, blame displacement, scapegoating, and a gradual erosion of the trust that makes collective action possible. The governance question deserves more attention than it usually gets. Who makes decisions on a Martian colony? In the early years, when the colony is dependent on Earth and effectively operated by a space agency or a corporation, the answer seems obvious. Mission control, the agency, the company. But as the colony grows and the colonists develop their own sense of identity and their own needs that diverge from the priorities of whoever is funding them from Earth, the governance question becomes genuinely complicated. The colonists will produce resources that Earth wants or can use. They will develop expertise and knowledge that gives them leverage. They will also be entirely dependent on Earth for resupply, at least initially, which gives Earth leverage over them. This is not a hypothetical political problem. It is the central tension of every colonial arrangement in human history, and the history of how those arrangements have typically resolved itself is not reassuring. Colonialism on Earth has an almost uniformly catastrophic record when it comes to the well-being of the colonized. Even when the initial intentions were benign, even when everyone involved believed they were doing something good. The Martian colonists, assuming the colony survives its first generation and develops something approaching cultural coherence, will almost certainly develop interests that diverge from those of their funders on Earth. They will want more autonomy. They will want control over their own resources. They will resent the communication delays that give Earth a structural advantage in any negotiation, because by the time they can respond to Earth's position, Earth has moved on. They will be physically, culturally, and increasingly psychologically separate from the civilization that built them, and that separation will intensify with each generation. We have never done this before. We have colonized other continents, but the colonized land was on the same planet. The colonized people could, at least theoretically, go back. They could receive reinforcements. They could communicate in near real time. None of that will be true for Mars. The colonists will be in a situation that has no genuine historical precedent, and they will be improvising their social and political institutions from scratch under conditions of physical stress and informational isolation that have historically destabilized much more robust social arrangements than a small group of pioneers in pressure suits. There's also the question of mental health infrastructure. Earth has, over centuries and with enormous cultural variation, developed systems for supporting people through psychological distress, therapy, community, religion, art, ritual, the slow accumulation of wisdom about how to grieve, how to celebrate, how to maintain meaning in the face of suffering. These systems are imperfect and unevenly distributed, but they exist. They have been built up over millennia by billions of people navigating the specific difficulties of being alive on this planet. Mars will have none of that, or rather, it will have whatever the first colonists bring with them and whatever they can build on their own. A small group of people, drawn from a narrow demographic and selected for technical competence rather than spiritual or psychological depth, arriving in the most alien environment humans have ever occupied and tasked with not just surviving, but creating a civilization, will need cultural resources that take generations to develop. They'll be trying to invent the institutions of meaning-making at the same time they're trying to fix the air recycler. The psychological literature on traumatic environments suggests that communities under sustained extreme stress often develop coping mechanisms that are effective in the short term and corrosive in the long term. Rigid hierarchies, scapegoating, magical thinking, dehumanization of outsiders, suppression of dissent. These are patterns that appear in isolated communities across many different contexts, from Antarctic stations to cults to high-stress military units. They emerge not because the people involved are bad or weak, but because certain kinds of stress narrow the cognitive and emotional repertoire available to a group, and the narrowed repertoire selects for behaviors that maintain short-term cohesion at the expense of long-term health. A Martian colony under perpetual environmental stress, with limited social diversity, with no outside community to provide a corrective perspective, with governance structures that are still being improvised, is exactly the kind of environment where these dynamics would be expected to emerge. And unlike a submarine that surfaces in 6 months, or an Antarctic station that evacuates in summer, a Martian colony has no natural escape valve. The pressure would not be periodically released, it would accumulate. There's one more dimension of this problem that is almost never discussed in mainstream conversations about Mars colonization, and it might be the most philosophically unsettling of all. It's the question of what kind of people are actually capable of choosing permanent exile. The first Mars colonists will have to be people who are genuinely willing to never see Earth again, not as an intellectual commitment, but as a lived reality. People who can watch the blue dot in the Martian sky and not feel the pull of it as an unendurable wound. People who can be present at the deaths of friends and colleagues without the support of their larger community, without the rituals that make death navigable, and continue to function and contribute and care about the project they're part of. Who are those people? The honest answer is that we don't fully know. Extreme environments do select for certain psychological profiles, and those profiles don't always look the way we'd expect from the outside. The people who thrive in Antarctica, for instance, are often not the most extroverted or the most obviously resilient. They tend to be people who have a highly developed capacity for what psychologists call self-sufficiency, not cold isolation, but a genuine comfort with their own company and their own inner resources. They tend to be people who find meaning in task completion and in contributing to a larger mission, who can experience boredom without it becoming existential, who can repair their own emotional states without requiring constant external validation. Those qualities are not randomly distributed in the population. They're actually somewhat rare. And the question of whether the people who possess them in sufficient abundance are also the people who would choose to commit permanently to Mars, rather than returning to Earth and enjoying a relatively comfortable life as a retired astronaut, is not obvious. The selection problem is real. You need people who are capable of living on Mars, meaning psychologically suited to extreme chronic isolation and physical hardship. But you also need people who want to live on Mars permanently, who have actually reckoned with what permanently means and made peace with it. And you need enough of those people in the same place at the same time to constitute a functional community rather than just a collection of extraordinary individuals, each managing their own private ordeal in parallel. That intersection, capable and willing and present in sufficient numbers, might be smaller than we hope. None of this means that Mars colonization is impossible. It is worth saying that clearly, because this kind of analysis can slide, if you're not careful, into a kind of intellectual pessimism that isn't really warranted by the evidence. Human beings have, repeatedly throughout history, done things that looked impossible from the outside. They have survived environments that were expected to kill them. They have built institutions and cultures and systems of meaning in conditions that seemed designed to prevent all of those things. The history of human resilience is genuinely extraordinary, and it would be unscientific to assume that the psychological and biological challenges of Mars are categorically insurmountable simply because they are profound. But what this analysis does suggest, fairly clearly, is that our current frame for thinking about Mars colonization is incomplete in some important ways. The conversation is dominated by engineering and economics, by rocket designs and launch windows and cost per kilogram to orbit calculations. Those conversations are necessary. They are also not sufficient. We need a parallel conversation, given the same seriousness and the same resources, about what it actually means to make human life on another planet genuinely livable. Not just technically feasible, not just survivable for mission durations, but genuinely livable in the sense that people who were born on Mars would look back on their lives and feel that their lives had been good ones, that the project they were part of was worth the cost it extracted, that the civilization they were building was building towards something worth the sacrifice. That conversation requires inputs from psychology, psychiatry, anthropology, philosophy, theology, child development, sociology, political theory, and the arts. Not just aerospace engineering. It requires the same kind of interdisciplinary seriousness that we bring to the engineering problems, which is to say, it requires serious funding and serious institutional commitment, not just occasional panels at academic conferences. And it requires honesty about what we don't know. We don't know how the human body responds to decades of 1/3 gravity. We don't know how children develop in that gravity. We don't know what long-term exposure to elevated radiation does to cognition over 40 or 50 years of life. We don't know how isolated small communities self-govern under indefinite extreme stress. We don't know what kinds of cultural institutions are capable of supporting human flourishing in an environment that has no natural beauty in the traditional sense, no open sky, no seasons felt on skin, no wilderness to retreat into. We know enough to suspect that these are hard problems. We don't know enough to solve them yet. And that gap between our technical trajectory and our human sciences trajectory is real and significant. If we close the engineering gap and land on Mars before we've done serious work on the human gap, we're likely to produce something that looks like a colony from the outside and functions like a pressure cooker from the inside. That might work for a while. It might produce some extraordinary people and some important discoveries, but it's unlikely to produce, in the long run, a genuinely thriving civilization. The deeper question that Mars raises, and that perhaps Mars is ultimately useful for raising, is about what we actually owe to the people who would live there. The colonization conversation tends to be framed from the perspective of Earth, of the benefits that a multiplanetary civilization would confer on humanity as a whole, of the insurance it provides against extinction, of the knowledge and resources and technological development it would generate. These are real and important considerations. But the people on Mars will not be representatives of humanity in the abstract. They will be specific individuals with specific needs and specific vulnerabilities, making specific sacrifices. The children born on Mars will not have chosen any of this. They will simply be alive in a place that their species did not evolve for, dependent on systems that require constant maintenance, facing risks that most humans in history never had to contemplate. With social and cultural resources that are still being invented in real time, what do we owe them? It's not a rhetorical question. It's the central ethical question of Mars colonization, and it's almost entirely absent from the current conversation. If we take that question seriously, some things follow fairly directly. We owe them the honest acknowledgement that we are sending people, including people who have not yet been born, into an experiment of unprecedented scope and difficulty, and that the outcome is genuinely uncertain. We owe them the best possible preparation we can provide, not just technically, but psychologically and culturally, which means investing seriously in the human sciences side of the equation long before the first spacecraft leaves. We owe them governance structures that protect their autonomy and their ability to make collective decisions about their own future, rather than structures that subordinate their needs to the financial and political interests of funders on Earth. And perhaps most fundamentally, we owe them the possibility of return. Not the guarantee, because the logistics of large-scale return missions are genuinely difficult, but the genuine possibility. Because a colony where exit is impossible is not a civilization, it's a sentence. This is where the comparison to Earth's colonial history becomes instructive rather than just cautionary. The worst outcomes of terrestrial colonialism were produced consistently by arrangements where the colonized had no meaningful power to leave, no meaningful power to govern themselves, and no meaningful representation in the decisions that determined their lives. They were produced by arrangements where the interests of the funders were systematically prioritized over the interests of those doing the actual work of building the civilization. They were produced by the fiction that the colonized were being benefited rather than exploited, a fiction that was genuinely believed by many of the colonizers, which didn't make its consequences any less severe. Mars colonization has the potential to reproduce those dynamics in a context where intervention from outside is even more difficult than it was in the historical cases. The communication delay alone creates a structural power asymmetry that has no precedent. Earth will always know things before Mars can respond. Earth will always be able to make decisions that affect Mars before Mars can contest them. That asymmetry, if not consciously and carefully counteracted, will have consequences that we can predict with reasonable confidence based on the historical record. The question of whether Mars colonization could fail is, in this light, slightly the wrong question. A more useful question might be, fail for whom? The colonization could succeed in the sense that a permanent human presence is established and maintained on Mars, while simultaneously representing a profound failure in the sense that the humans who live there are not flourishing in any deep or sustainable way. Those two things are not mutually exclusive. And the history of our species suggests, rather powerfully, that we are capable of building things that endure for centuries and simultaneously represent ongoing catastrophes for the people inside them. The real reason Mars colonization could fail is not that the rockets won't work. They will work, eventually. It's not that we can't solve the radiation problem or extract enough water from the Martian regolith. We'll solve those things too. The real reason it could fail is that we might get there before we've seriously reckoned with what it means to ask human beings to live there. Before we've done the hard, slow work of understanding what makes human life genuinely livable and built the frameworks to support that livability in an alien world. And if we get there without having done that work, we won't necessarily know it has failed right away. The first decades might look like success from the outside. There will be habitats. There will be breathable air and drinkable water and some form of food production. There will be scientific achievements and political announcements and photographs that make people on Earth feel something between pride and awe. But inside those habitats, if we haven't done the work, there will be people paying a price that wasn't fully counted in the mission plans. People managing a level of psychological stress that is slowly becoming too much. Children growing up in circumstances that they'll spend the rest of their lives processing. Communities developing the pathologies that isolated high-stress communities reliably develop, and without the external corrective that Earth-based communities have always been able to draw on. The failure, if it comes, will look like that. Quiet, interior, not the dramatic explosion or the catastrophic decompression. Just the slow, invisible process of human beings coping with too much for too long without enough support, and the things that process produces in communities and in cultures and in the generations that those communities and cultures shape. There's a concept in architecture called habitable space. It sounds technical, and it is technical, but it also carries a meaning that goes beyond square footage and ceiling height. Habitable space is space that actually works for the humans inside it, not space that merely keeps the elements out, not space that is technically occupied. Space that supports, in the deepest sense, the people who live there, that is comfortable and scalable and adaptable to the changing needs of communities over time. We have not yet designed habitable space for Mars. We have designed survivable space, pressurized space, radiation-shielded space. These are genuine achievements, and they are necessary preconditions for what comes next, but they are not sufficient. Making Mars genuinely habitable, in the full sense of that word, is the work that lies ahead of us, and it is, by any honest reckoning, the harder work. Not because we lack the intelligence or the creativity to do it, but because it requires us to ask questions that don't have clean engineering solutions. Questions about meaning and community and belonging and grief and the things that human beings need from each other that we don't fully understand even here on the planet we evolved to live on. Mars will not let us avoid those questions. If anything, it will force them into sharper relief than they've ever had before, because the consequences of failing to answer them will be written in the lives of real people in a place where there is no rescue, no alternative, and no going home. There is something both humbling and clarifying about that. The Mars project, if it is done well, could be one of the most honest things humanity has ever attempted. An honest reckoning with what we need, what we can endure, what we owe each other, and what we're willing to sacrifice, and for what reasons. An honest confrontation with the gap between our ambitions and our understanding of ourselves. We have been reaching for Mars in our imaginations for a very long time. Now we are beginning, finally, to reach for it in practice. And the difference between reaching imaginatively and reaching practically is that practice makes demands. It asks you to show up not just with your vision, but with your limitations. Not just with your plans, but with your blind spots. Not just with your best-case scenarios, but with your honest assessment of what could go wrong and how you will respond when it does. The question that hangs over all of this is whether we are willing to do that work, not just the engineering work, though that too, but the harder, slower, more uncertain work of understanding ourselves well enough to carry ourselves successfully and humanely to another world. That work has already begun in small ways, in isolation studies and in psychological research, and in the growing field of space architecture, and in the quiet, unglamorous conversations that are happening in meeting rooms and research labs between people who care deeply about getting this right. It is not yet happening at the scale that the challenge demands, but it is happening. The rust-colored landscape is still there. The hillside, the rocks, the sky, the color of a faded bruise. Nothing moves. Nothing ever will. Not on its own. But we might. And what we bring with us when we go, not just in the cargo manifests and the engineering specifications, but in our understanding of what humans need in order to flourish, will determine more than anything else whether the thing we build there deserves to be called a civilization. The rockets are almost ready. The question is whether we are.